All right, everyone, we're going to jump right back into the series in CAD. Today we're going to talk about construction geometry. As much as some might think that this is an obscure topic and maybe not as useful as they hope, I would definitely argue the contrary. It's something I use pretty regularly. There's a ton of use case for it. The first one that I could think of is going to be, well, actually, we'll discuss construction geometry and then get into that. So when I say construction geometry, I mean points, axes, and planes. An axis can also be thought of as like a line, and they're useful for constraining objects or for defining features in the part that can't be defined off of features that already exist. Um, because it's not modeled, let's say you need something at a weird angle or something else like that. You don't. It might be a little easier to see as we dig into it. So, extremely useful. And the one that I could think of that I use the most often is going to be for something like mating a helicoil or a spring. So think of just a piece of wire that's wound in a helix, essentially, anything like that. There's no conical or cylindrical face to constrain the center of that part to the hole or the shaft or whatever it is it's going to be mating to in an assembly. So a lot of times it's easier to make an axis defined off of the origin planes that are usually defined at the center of the part when you import the file from McMaster or wherever else you're getting it from. It's just really convenient. So that's kind of the first thing that I think of. Now, before we get into what Fusion is doing and how to use Fusion and this kind of stuff, we're going to talk about geometry. I know everyone's kind of eager to touch on that topic, but we're gonna talk about that. So it's going to be start with a point, which is considered like a zero-dimensional object. It's a point is essentially just a location in space. It can be in 2D or 3D. So 2D would be just think of a piece of paper and you draw a point on that piece of paper. You can, if the bottom left corner of that paper is 0, 0 in terms of, the left edge of the paper is your y is equal to 0, and the right edge of your paper is 8.5 inches. So your y-axis goes from 0 to 8.5, and then your x-axis goes from the bottom to the top, so from 0 to 11 inches. Your bottom left corner, or wherever you define 0, you can do it in either direction really, is going to be 0, 0. So that means that if you drew a point with a pencil anywhere on that paper, it's going to be some location away from the bottom edge and some location away from the left or the right edge, whatever you define as 0. And wherever that measurement is, that's the location of the point. Now, if you extruded that out, so like a three-dimensional piece of paper, and you threw a point, drew a point somewhere in there, kind of like in this room, if I held my finger up, wherever that is relative to, let's say, that bottom corner behind me, back there behind the chair, if that was, if this was y is equal to 0, that wall is x is equal to 0, and the ground is z is equal to 0. Wherever, if I put my finger up here and I measured off those three walls, wherever that finger is, right at the tip, that's going to be, I don't know, my XYZ coordinate, whatever that measures out to in feet. So that would be how you define a point. Now you can move on to a one-dimensional object, which is just an axis, or in most cases you can just consider it a line, and it's got 0 thickness, it has 0 diameter, it's got no size except it's infinite in length. So in whatever dimension it's drawn or it's sketched in, whatever you want to do, it's infinite in that length. And you can usually define, this is the most common way, is going to be with 2 points. So you connect 2 points like point slope form or whatever we did in geometry, and that's how you're going to define a line. And moving up from one-dimensional to two-dimensional, you get into a plane. And a plane is just a flat object in space. And what I mean by flat is it doesn't have to be parallel, it doesn't have to be horizontal or vertical. It can be in any orientation it wants. It just means that by flat, and this is going to be covered when we go over GD&T, is that there's no peaks and valleys. It's just a perfectly flat, smooth, even surface. It's like a piece of glass, but you can hold it in an orientation you want. It's still flat. It's infinite, though, in both directions. So if you held a piece of paper up, it'd be infinite in this whole plane, in whatever orientation it is. It's just infinite in this direction and in both directions. So And you're going to define a point in a couple methods. You can use 3 points, so you just pick 3 points in space. Get used to having a camera here. So you just have 3 points in space. You can define it with a line and a point. So if you just have a line drawn somewhere in space and a point, if you connect those, the line and the point, you create a plane. You can also create a plane or define a plane using 2 lines. Not all 2 lines will make a plane, but it's in certain cases you can use 2 lines. So we're going to jump right into Fusion. We'll try to get through this without anybody falling asleep. So if you have Fusion open, I drew a very rudimentary part. It's got a full round fillet and just some sort of rectangular 3D shape here. So up here, we're going to go to Construct. If you hit the drop-down menu, you're going to get to the same exact thing that I'm about to go through, or you can go ahead and click the construct up here. Either way, you have your planes, your axes, and your points. These are essentially ways to create planes. These are ways to create axes, and these are ways to create points. So you have a lot of different options depending on what you're trying to do. Go ahead and click the construct. You have your planes here. You have your axis here in this pop-up menu, and then you have your points. Just to start with 0 dimensional, we're going to go with point. And for point, it's pretty redundant because they're just different ways of defining a vertex, essentially. So at vertex, so vertex means that you're just going to find the intersection of 3 lines, or 3 edges. That's how they're going to call it in Fusion. So this is considered an edge, this is an edge, and this is an edge. So wherever the 3 of them intersect is going to create a vertex. So we're going to go ahead and click that. And that now is a point in Fusion. So if you go ahead and click OK, notice that in your tree, mine popped open because I was playing around with this earlier and I was opening and closing this menu, but you may have to click the drop-down menu. It pops up. You can hide it. You could show it again by clicking it again, but that's where the point is. Now, just to clear things up in space, in our workspace, we're going to go ahead and go down to the timeline down here, right-click on the point, go ahead and click Delete. Now it's out of the way. We're going to go back up to Construct, go back to Point. From there, we're going to go through 2 edges, and like I said before, this is kind of redundant, just because we're kind of doing the same thing over and over again. But we're going to go ahead and click an edge, and we're going to go ahead and click an edge, and notice how they intersect. Wherever the 2 edges intersect, it's going to create a point. It's going to create the point right at the same place we just already defined. So basically, we're going to define a point somewhere along this line. And then by selecting this line, we're saying, okay, it's intersecting this line at this location. That's where I want the point. That's essentially all Fusion is asking for, is where do I drop this point? And that's how you're going to define it to Fusion, or any CAD package for that matter. So then if we go to the next method, and it kind of gives you a little explanation here if you hover over it, but kind of just show you what that means visually instead of reading through it. So through 3 planes, again, just pick 3 planes. You're going to go ahead and define the point right here. They don't have to be orthogonal. It doesn't have to be some sort of rectangle. The 3 planes just have to intersect. So if I go ahead and get rid of this plane, for instance, and I wanted to select this one, for whatever reason, if I wanted to, you can't. And if you think about that physically, this plane will never intersect this plane. It'll also never intersect with these other 2 planes at a single point in space where a point can be drawn. So that'll never create a point with that selection. So Fusion will tell you if something isn't possible. It's probably not wrong. I think the guys that developed it probably know their geometry pretty well. So I would trust it. Not blindly though, but it should tell you when something is physically not possible. And the next one is going to be at the center of a circle, a sphere, or a torus. A torus is like a donut shape, so if you go ahead and click this, it's going to be useful for something like the circular feature. So if I wanted basically the center of this circle to have a point on it, I go ahead and just click that edge. I can do the same thing on this face. Depending on what face I wanted it on, I can have that reference point. Go ahead and click to the next one, at edge and plane. So it's asking for some inputs. So let's say we want a point on this edge and we want it on this plane. So basically what it's saying is somewhere along, same thing we just talked about earlier, somewhere along this edge, is going to be a point. Wherever this plane intersects that edge, it's going to drop a point there. So in this case, it's going to be right here. Now, we can go to, you can have a long path, so if you had a path drawn, you can add a point to it. I've never used it. I've never seen a reason for it. There may be, if we ever come across it, we'll touch on it. I don't think it's something worth discussing right now, so we'll jump back into that at another point. Maybe we'll do it, we're definitely going to do a design project together. We'll do something pretty moderately complicated. We'll step up in complication or complexity. But for now, we'll just pass right over that, and we're going to go straight to axes now. And the first one is going to be through a cylinder. So just think of a cylindrical object. You can do a conical shape or, again, another donut shape. So that's what an axis is going to look like. And let's just go ahead and create this one, the first one, while Fusion thinks. Again, it pops up here. It'll be named an axis. And you can go ahead, if you click the ends, right when you see that little white orb pop up, you can go ahead and just drag it. And like I said earlier, an axis is like a line that's infinite in length, so it'll just go up and down in infinity. I don't want that showing. I don't really care about having it, so I just want to get rid of it. Go ahead and click delete in the timeline. We're going to go back to axes. We're going to go to a face. So just for the fun of it, I'm going to select this face. And it's already visualizing an axis. I'm not sure why it's doing that right now, but I've selected this face back here, and then I need to select a point that that axis is going to pass through. So let's do that point. So basically the inputs are saying, hey, there's an axis that's going to intersect this plane, and it's also going to be perpendicular to this plane. Now you need to pick an edge, or a point, sorry, where it's going to pass through that plane and perpendicular to it. So that's what the purpose of the point and the plane are. Moving through to two planes, you can go ahead and select this one and this one. You'll get an axis there, but notice how if I try to select the opposing face, this one here, it won't select it because those two planes never intersect at one point. Let me go ahead and plug my laptop in here so we don't lose battery life. And so you'll never get an intersection of those two planes if they're parallel. So that's the physical meaning of why you can't select that. I'm going to go ahead and turn the brightness up here. And as we move through to those two planes, we're going to go through 2 points. And this is probably the most intuitive and probably the way everyone knows how to draw a line, because our geometry teachers drilled this into our minds as young children. Just click 2 points, and now you have an axis or a line drawn through any 2 points you can select. And then we're going to go through an edge. This is pretty trivial. So you can just click an edge and it'll create an axis over top of that edge, for whatever reason you might have. I've never done that before, or had a use for it. But now you know how to do it. And that completes axes. Go ahead and click planes, and this is where I think most of my time is spent when it comes to construction geometry. So let's say for whatever reason I wanted the mating part to be on this face, or I had a feature that was 60 millimeters offset, whatever that might be. I can create the plane here. You can define your offset here. You can also click the extent, meaning do you want it referenced to another surface, another feature, or whatever that might be. You can use that certainly. And extended means it's a little bit bigger than the face, or default is basically just the size of the face that it was referenced from, so the plane that you selected here. In most cases, you're probably actually going to have it going the other way into the part. So the first thing that comes to mind is on something like an O-ring groove or some sort of ceiling groove that doesn't have a geometry that you could just sketch in this plane and just extrude into the part. So it's going to be something like a dovetail groove that you maybe want to extrude in a circular fashion for an O-ring or something like that. So for those that have never seen or heard of a dovetail groove, think of a feature that looks like this. So this doesn't bring us somewhere. Oop, I was hoping that picture was going to blow up a little bit. But this is kind of a dovetail groove. So basically you shove, for the most part, this is used with O-rings. Think of it here. When you shove the O-ring in, this trapezoidal feature is slightly smaller than the diameter. And when you press it in, it just makes sure, actually this is a pretty good image right here. It makes sure that the O-ring just doesn't fall out. So if you had a part that was like upside down or something, when assembly guys put the O-ring in, this doesn't just fall out. So otherwise you'd constantly be fighting, and it would be very pleasant to put that in. So that's kind of that's what a dovetail groove looks like. The geometry is all different. There's a bunch of different ways to cut it and make it, and some people love them, some people hate them. Different topic for a different day. But you can't sketch that in a perpendicular plane here. You would have to sketch it in this plane, and then you'd have to use a revolve cut to make it in this plane. So that's why you'd want to use it if it was like an internal feature or something like that. That would be the purpose of this offset. If I just go ahead and click OK, just so you can see what a plane looks like. You can go ahead and kind of drag it and make it as big or as small as you want. And again, it pops up in the model tree right here. I'm going to go ahead and delete it so it's out of the way. I like a very clean workspace, just personal preference. Now, if you didn't have a translational offset, but you had an angular one, you can go ahead and just click an edge or an axis or something like that as a reference. And now the plane is going to revolve somewhere, or we're going to revolve around that edge. You can set the angle. You can do two objects. You can have a bunch of different references. And again, you could change its relative size, or at least the starting size, and change it later. And then as you move to tangency, we're going to talk about tangency real quick. So what I mean by tangent, and we're going to sketch this in 2D before we talk about it. So draw an arbitrary line there. And then we'll go ahead, this is at the center. So go ahead and use the SolidWorks. The window pops up and gives you suggested references for mates. But tangency means that a line that you draw touches the outside or the perimeter of an arc at a certain point, and at that point it is perpendicular to the radius. So this line and this line are, or this line and this curve are tangent at this point because it is the radius away from the center and is perpendicular to the radius. That's what tangency means. And that can be at any angle. I didn't define the midpoints, that's why it's kind of dragging everywhere, and it just decided it wants to be perfectly vertical. So that's why it's doing that. But that's tangency in a nutshell. That's bringing it back to geometry. We'll cover that more as we go into the basic math you need as you get into engineering or just kind of design in general. But we'll go right back to the tangency. So if you go ahead and pick a cylindrical or a circular face like that, you click the face, and then you can set a reference. You can also just set an angle, so you can have a tangent at sort of any of these, or an infinite number of angles essentially. And then you can also have it referenced to another angle. So right now there's a 10-degree offset, and we can go all the way to 135. So basically it's forming a 135-degree angle in this orientation here, however you want to define it. So you can click whatever reference plane that you want or feature, and that's how you're going to set the orientation of the plane. And then as we go through to midplane, and if I'm going through this quickly and there's more questions, drop them in the comments, talk in more detail about them in another video, or we can set up an email, however that works best. Probably another video, because if there's one person that has questions on it, it's probably quite a few. This is the most useful this is what I use all the time. SolidWorks has a way that's a little more efficient to do this because there's a constraint called midplane. But if I was using anything else, any other CAD package that didn't have that, this is absolutely the way I'd be constraining parts in the midplane or creating features. So you go ahead and just pick two planes. They don't have to be parallel. They don't have to be, they can be whatever they want to be. They can be perpendicular and it'll create it at a 45-degree angle. You can do all sorts of different things and you can set the plane right in the middle. And I highly recommend if you want something in the middle, please do it with the midplane. Please do not do the math by hand, the width between your two features or surfaces or whatever, and then cut that in half and do an offset. There will always be an instance, it'll bite you in the behind at one point in time or another where you make a change to the width, but you don't update that offset, and then later on you realize it and the part comes in after you spend a couple $100s on it to get it machined and it's just not what you need and you have to find a way to work with it or order another part. I highly recommend doing it with the midplane because if you ever change a dimension, it'll always update with you. So please do it this way. You'll save a bunch of time, a bunch of headaches. It's also easier. You don't have to do any math. You never have to pull out paper or anything like that. So it's right there for you. Now you have, I've never seen any of these, or never used any of these, I'm sorry, but you have perpendicular plane. This is actually, I was looking at this the other day. I don't remember seeing this. So we're going to learn this one together. So it's asking for a face and then another, let's say a reference. Okay, so it's going to create a plane that's perpendicular to a plane that you select. We're learning this one together. I didn't see this one when I was reviewing, taking some notes on this one. So this one, so you can pick a direction. So it's just going to assume that your plane's going to be perpendicular to this. So it's either going to be in this orientation or it's going to be in this orientation. So it's assuming, I think, vertical. The U direction it's defining two directions, the U and the V. So you can pick the two default directions, or I guess you can pick a reference. Oh, that'll be the location where it is. Okay. So what it's defining is you can pick in the two directions that are orthogonal based on whatever plane you select. And then from there, you're going to select a reference, so a location along that direction. So now you can define this location, or if you had it in the other direction, you can set the location. I probably, if I was creating a plane, this isn't the first method I would use. I feel like there's more inputs that are needed and a little more opportunity to make a mistake. So if I was looking to make a plane, I'd probably do it a different way. There are other ways of doing that. Probably with the offset and the angle or something like that. Certainly there if you want to use it. It's just another tool to have. So it could never hurt to know too many. Now you have through two edges. So let's say edge 1, edge 2 creates a plane. Notice how if you select an edge, you'll create a plane there. And then if you try to select, we're going to find an edge now that it can't intersect. So if you try to select this edge, you can select that one, can't select this one. So basically, any of the vertical ones that it doesn't intersect, you won't be able to create a plane because the two lines, you can't draw a plane through a line in this direction and a perpendicular line in this direction because you'll never have a flat plane. There'll be like a twisted helix that's trying to make some sort of surface, and it's not going to be a flat plane. So that's how you create it with two edges. Not something I've used either. Certainly there if you need it. In geometry, this is probably the first way that we're taught how to draw or define a plane. So let's say we use this point. Let's just get real fancy. We use this point and we use this point. So now you have a plane that kind of cuts the shape sort of in half. And the way I like to think about this is you can you can't define a plane with 3 points that are on a line, and I never really understood why until I don't know much later. I was probably in one of my calculus classes. I think it was Calc 3 because you start thinking in 3 dimensions with calculus. So if you had a line drawn from here to here and you had another point along this line, essentially what this point up here is doing is it's saying, okay, so the plane is running in this direction. This point essentially sets the rotation. Let's do this in another orientation that's a little easier to see. So here and here. So now the point or the plane is essentially in this going to run along this line here, and the third point sets the rotation. So basically this acts as a center of rotation that allows the plane to be fully defined. So that's the purpose of the 3 points. That's why it's doing what it's doing. And then you go down through, the last one's going to be along a path. I'm not going to cover that. I've never used it. I don't plan on using it. I've never seen a use for it. Maybe we'll try to find a project where that makes sense to use or to design a part, but for right now, we're going to end that there. I touched on this because I actually started making a video on lofts and sweeps because I think that's going to be the next logical step in learning extrusions and 3D parts. But in order to do lofts and potentially sweeps, you would need to know how to set planes. So I figured construction geometry would work next. We're gonna jump into those in the next video. I have a couple more in CAD. I want to talk about a syllabus. I got a couple other projects and some friends that run businesses with in the automotive world, motorsports, and some other friends that kind of want to be involved with the channel. So a lot of fun upcoming projects. Going to be a little more regular now. Moved into a house, so got my own garage and turning that into a shop, my own office that sharing with my wife. She's got her little Bible study going on. And the desk behind me that you saw as my demonstration with the corner wall there. So thanks everyone for watching. Catch you in the next one.